Hi everybody, so I'm just going to take you through how to calculate your maximal heart rate. So there's a couple of ways to do this. There's a very straightforward calculation. It's called the maximal heart rate calculation. And the second way is a little more complicated, but it's much more accurate. And that's called the heart rate reserve, or it's also called the Karvonen method. Okay, what I've done is I have done up the calculations already for you. Okay. So over on this side, we have, oops, hang on, no, that's not what I want. Sorry, technology. Okay, so over on this side, we have the heart rate. So this is the maximal heart rate calculation. What you do over here, the first thing is, this is the calculation. So maximal heart rate equals 220 minus your age. That's pretty much the heart of the calculation. So long as you know your age, you're going to be right. So you basically go 220 minus your age, and then the second part to it is that you just multiply this number by the intensity that you want to work at. Jane, as an example, Jane is 30 years old and wants to train at 85% of her maximal heart rate. So your target heart rate is equal to your maximal heart rate times by the intensity. So we calculated the maximal heart rate at 220 minus your age. So Jane is 30, that wasn't a very good line. So then we go 220 minus 30, which equals 190. And we're timesing that by 0.85 because she wants to train at 85%. So 220 minus her age of 30 times by 0.85. So target heart rate is going to be 190 times by 0.85. which gives us a number of 161.5. Now, you can't ask someone to work at 161.5 beats. It doesn't work like that. So Jane's range over here is 160 to 165 beats per minute, and that has her working at 85% of her maximal heart rate. Now, the reason why we do this, now the 220 has basically been calculated, by some very smart people who've done a lot of math and statistics. But one thing we know is that as you get older is that your maximal heart rate comes down. Obviously, you can offset this by getting fit and by exercising continuously. So if you've exercised pretty much your whole life, this calculation is absolutely not going to work for you. It's going to underestimate, the intensity that you should work at. However, if you're unfit at the moment and not done a lot of exercise, this calculation is probably just fine for you. The second way to do this is called heart rate reserve. Sorry, that wasn't a very straight line. So the first thing you do is calculate your maximal heart rate in exactly the same way, as what we did the first time. So 220 minus your age. Now, this is where the calculation is a little bit more complicated. But if you follow it step by step, just like a math equation, you'll be right. This is the equation. Target heart rate is equal to maximal heart rate minus the resting heart rate times by the percentage that you want to work at, and then you add the resting heart rate back on again. Now, the reason why we do this is because we're not starting at zero. Our resting heart rate is not zero. So that is our base point. That is our starting point. So you add that back on, and I'll do a little drawing for you in a second to hopefully make it a bit more clear. So we've got Jane again, 30 years old, still wants to work at 85% of her maximal heart rate, but now we know her resting heart rate is 60 beats per minute. So following the equation, target heart rate is equal to maximal heart rate minus resting heart rate, times it by the percentage, and then add on the resting heart rate. So her maximal heart rate, as we calculated just before, is 190. That's 220 minus 30, which is her age. So 190 minus 60, because that's her resting heart rate. She wants to work at 85%, so 0.85, and then we add back on that resting heart rate again over here. So 190 minus 60 equals 130. We're going to times that by the intensity and add back on her resting heart rate. So we now get a target heart rate of 170.5. Now again, you can't get someone to work at a specific number like that, and you certainly can't get them to work at a half a beat. So we give her a range of 170 to 175. So as you can see here, there's a difference of 10 beats per minute between the two calculations for the same person. So it does make a difference when you've got someone who is quite fit. So if you are fit and healthy and you've been exercising for a long time, I would suggest that you use this equation. Now, the reason why we use the heart rate reserve is I'll draw this for you. Now, it's not going to be the most amazing line, but anyway. Okay, so if this end down here is your resting heart rate, and then this end up here is your maximal heart rate. Theoretically, this is as low as your beat, as your heart can go. That's as slow as it can go. And this end up here is as high as it can go. So we have in between here and here, this is the amount of beats your heart is able to do. So the resting heart rate, sorry, just go back here. And this is what we call your heart rate reserve. So it is basically the difference between the slowest beat you have, or your resting heart rate, versus your fastest or your highest beat. I'm not sure if I'm explaining this very well. I hope I'm not making this worse. So theoretically, Jane's lowest heart rate is 60. Theoretically, her highest heart rate is 190. So 60 is her lowest, 190 is her highest. Therefore, the heart rate reserve is what we find in here, which is 130. And that's what we calculated over here. Now, if we were to calculate 85% of 130, the problem is I'll tell you what that is as I quickly calculate that, is that it is 110 beats per minute. As per usual, we've got Felix coming in. I'll ask you. No, not for this one.
Hi.
Off you go. So it's 110 beats per minute. Now, if I was to tell someone to work at 110 beats per minute, the problem with that, obviously, is that that's a very low heart rate. You could easily get 110 beats per minute by just walking up a set of stairs. And if you have a look at her maximal heart rate here, 110 beats per minute is somewhere down here. And we want to work at 85%, which is going to be, somewhere up here. So we know that 110 beats per minute is not correct. And that's why we add back on that 60, because we haven't started at 0, we've started at 60 beats per minute. So there's her heart rate reserve here. We add back on the resting heart rate, and then that gives us 85% of her heart rate reserve. So I hope I've made that more clear, and I hope that makes more sense. In terms of calculating heart rate reserve, you don't have to do this. Remember, this is really useful for people who are already training and who are already quite fit. When it comes to HIIT training, just so you know, so the researched HIIT, particularly that 4x4 program I was talking about, that's meant to be 85 to 95% of your heart rate reserve. So it's pretty intense. It's meant to be almost maximal. You can use this maximal heart rate calculation over here where you do 220 minus your age and that just times it by the intensity, but I would only suggest using that if you've just started out exercising. So I hope that helps. If you've got any questions, let me know. If you want some help calculating, it only takes me a couple of minutes. Chuck your resting heart rate at me and I will do a few calculations for you. All right, bye everybody. I'm just going to save this first. Save that and get out of here. All right, bye.